Yeah, so I'll just do a couple. So how about we focus on question 4 here. An oil tank has a capacity of 32 cubic meters. Okay. A similar oil tank, right? There's the word similar, right? Similar oil tank has dimensions that are larger by a scale factor of 3. Okay, let's write that down. Larger by a scale factor of 3. That's what you should read when you see that. Okay. Obviously, if it's larger, k will be greater than 1, and it is. It is 3. So there it is. Larger by a factor of 3. So what would you call this? An oil tank has a capacity of 32 cubic meters, and then there's a similar with a scale factor of this, right? I would call this the original, right? Would you agree? So capacity of original is 32 cubic meters. Okay. And so they're asking, what's the capacity of the larger tank? Capacity of, we're going to call this the new, right? What is the capacity of the new tank? So boom, that's my question right there. I fished out what I really need. They didn't ask for a scale factor, so it's just this. And they give me the capacity of one, I need to find the capacity of the other. All right, so given that, right, this is critical right here. Even if you didn't understand the word capacity, as soon as you saw the unit cubed, you knew its volume, it's 3D, right? So you need to use, right, because of this, you need to think k cubed, right? So I'm going to do that right next to it on page 25. So I'm going to say k cubed is capacity of the new over capacity of the original. And so k is 3, so it's 3 cubed is equal to capacity of the new is unknown. We're going to call that x. And the capacity of the original is 32 cubic meters. Okay. So then you cube it, and that is 27, right? 3 cubed is 27 over is equal to x 32 cubic meters, like that. And I don't know about you, but sometimes students miss the fact that 27 is really a fraction. It's a fraction over 1. Right, so that's just a trick. No way, right? Say not so. So anyways, it's 32 times 27 divided by 1, which is irrelevant, but I still want to have that because it could be something other than 1. Right, so it's really 32 times 27, and that's 864, and we are in cubic meters, right? That's what you started with. So that's the unit, those are the units that would go with us. So these, you can count on these types of questions on the quiz, even on the test, right? Like you're given a scale factor, you're given partial information, set it up properly, and then go with it, right? So this would be the final answer here that I'm after. Let me see. I'm going to scan here. I think I'm going to go with 6, question 6 here. I'm just going to write that on page 25. So Brenda's a potter. She's creating 2 similar vases, right? With their dimensions related by a scale factor of 3/4. So there it is. I'm going to make note of that. So my scale factor is 3/4. Done. Okay. And then the larger phase has, so here you have to be careful. I like how they did this. They're defying Mr. Dirksen's wording here. So the larger one, I'm going to stick with that. The large is 9420. Okay. Volume of large is 9420. And that is in cubic centimeters again. Okay. So they want to know the volume of the small. That's unknown to me. Okay. So obviously, because we're in cubic units, we're thinking cube, right? 3D. So yes, we got to start like this. But where do I put what in this case? And how are you going to determine that? It's important to know where the number goes, right? The 9420, does it go up or does it go down? Because I don't know, Mr. Dirksen. I don't know which one is the original, which one is the new. What would you say? Which one of these two numbers is bigger? The 4, right? Because remember, this one is, and it could be the new, right? And this could be the original. But not only that, in this case, it actually also tells you which one was the larger one. It's this one, right? Large, right? Large, and this is the small one. Just look at the numbers, right? 3 and 4. So sometimes that is your guide. Look at what the scale factor, especially if it's as a fraction, right? Then that's going to guide you, right? So let's go. That means that this would be volume of large, volume of small. I'm going to match it. I based it on the scale factor that I was given, right? Should I make a note of that? Little note. The scale factor told me where large and small goes. Can you read that? Sorry, guys. My camera skills are still developing, okay? So if I'm off, if it's not even showing up when I write, please let me know. I don't always notice. But the scale factor told me where large and small goes, because it's not always going to be in this order. It's the scale factor that gave me that. Sometimes it's the wording. In this case, I use that. Okay, so let's go. 3/4. Don't forget to cube it. It would have been squared if we would be talking about area, or if you notice that your units are squared. Okay. So this is my unknown, and this is 9420 centimeters cubed. So here we go. If you cube that cube, 3 cubed is 27. 4 cubed, anybody remember? 4 times 4 is 16 times 4, 64, right? And that is x over 9420 centimeters cubed. X is simply multiplying and dividing. That's why homework is so important for you to do, because you come across these things. And I wish I had more time to do all of them, but I can't. I can't do every scenario. And I don't know what the answer is, so I'm going to actually have to. I just decided to go over this. Those of you that did your homework, you are probably just making little notes here and there, right? I don't want you to forget this. What if the question asked you to turn this into a cubic inches? So this is for all intents and purposes, this is the answer, right? We're done here. But let's say on a test, I say, hey, I want you to now state your answer in a different unit, right? So there's that extra challenge, right? Convert cubic centimeters to cubic inches, right? Convert cubic centimeters to cubic inches. How would you do that? I would take the 397406. Ideally, I would want to use all decimals, but we're assuming that this is like a part B to this question. Okay. Did I give you this one? 1 inch has 2.54 centimeters. I'm fairly certain I did. Let me just check the front of this booklet. Yeah, right there. Right there. So here, some of you don't need to do this step anymore. So you will just go on the side here and you will do this. 1 inch, right, has 2.54 centimeters, right? And you just take the whole thing. I just tripped there in my wording. 1 cubic inch, just cube this one. Uh, 2.54 to the power of 3, and you just have that on the side here, 16.387, and it keeps going, squared centimeter, cubic centimeters. Okay, so you do that on the side. You're following me, right? You do the cubing on the side. You take the linear ratio that I gave you. Hey, I want cubic centimeters. I'm going to cube the whole thing on both sides. Really, the action is happening on the right side here. So now you come over here, and you know that 1 cubic inch has 16.387. It's okay to just go like this, dot, 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 okay? I'm assuming you're using the entire, like all decimals there. So I'm going to go 3974.06, basically divided by this, right? I'm going to just copy paste. And so that'd be 242.51. 242.51 cubic inches. Don't forget how to do that. Okay? Don't forget how you can do any squared to squared, cube to cube. Just follow these steps, right? Go get your linear conversion rate, either squared or cube it, and then use it to make your conversion, right? I don't think you did this in IPR, did you? Areas, converting areas and cubic. I don't, maybe. I think what they would have done, depending on who was your teacher, they would have converted before, right? Give me the answer in cubic inches. You may have, like if you have your dimensions, you convert them all to inches and then just find your volume. Or, but this is actually the same thing that you're doing. It's just doing it at the end because we don't know the dimensions of this cylinder or these cans, right? All right. Anything else? Anybody have a pressing question here? No questions? Yep. 7? 777. Okay. Sure. Let me read that. The dimensions of the right octagonal pyramids are enlarged by a scale factor of 1.5. Determine the value of each of the following ratios. The volume of the... Okay. All right. I like this one. You cannot write in your textbooks, okay? And I actually don't want to highlight this either because then I can't use it. But do you notice that here we're comparing the volumes, 3D. Here we're comparing surface area, 2D. And here, perimeter, whether you realize that or not, that's one-dimensional. Perimeter is just length, right? It's just adding up all the lengths. So this is 1D, 2D, 3D, okay? Determine the value of each of the following ratios. So if you were to divide their volumes or divide their surface areas or divide that, what would it be? I actually like this question a lot, and I will tell you where we go back to. We're going right back to the beginning of this section. If you were to take both surface areas, right, and divide them, we got 4, right? That ended up being what, really? It ended up being k squared because we're comparing areas. If you divide your volumes, if you divide the volumes of the similar shapes, you end up getting, in this case, 8, which was really k cubed. Are you following me here? When you divide the volumes, you're going to get k cubed. When you divide the areas, surface areas, you're going to get k squared. So what this question is trying to do here, back to 25, okay? Question 7. We know that k is, was it 1.5? Yeah, we know that k is 1.5. So the original has been increased. We know that because it's bigger than 1. Therefore, here's the therefore. If you compare the volumes, right? If you go volume of the large divided by volume of the small, right? If you divide them, you get k cubed, right? And so 1.5 cubed would be, I need help on that one, 3.375. If you divided the volumes, you would get this, okay? If they have been affected by this factor, if you made it 1.5 times larger, this is what you would get. Dividing surface areas, it would be k squared, which is 1.5 squared, which is 2.25. Let me double check that. I'm thinking 15 squared. Yeah, it's 2.25. Dividing perimeters, it's just k, which is just 1.5. Can we put this one-dimensional, two-dimensional, and here it's three-dimensional? So if we just compare their perimeter, or even if it would be length or height or anything one-dimensional, would just be the scale factor itself. If you divide the resulting surface areas, it would be 2.25 k squared. If it's volumes, it would be k cubed. Does that make sense? Just say yes or you'll leave us alone, right? But that's the idea. I'll show you later on. I love, my son started 3D printing at his school, and he introduced me to Tinkercad, I think it's called. Some of you might have heard of it. I'll show you. I actually love, you can draw it to scale, right? Make things to scale and see how it would fit in there. So if you take their volumes and you increase it by this much, you could probably fit the smaller item into the larger one just over 3 times. So it's kind of cool that way. Okay. All right. I can't do them all. Sorry. Got to cut it here. But if you have questions, come and see me. I'm going to give you a short NAC in a bit, but I wanted to warm you up a bit. Let's go to page 20. So I'm kind of getting you ready for tomorrow's quiz. I know it's coming up, right? It's just what? Tomorrow, right? But I did put it on there already a while ago. So I just need to focus on this because I know this one is the one that students find challenging. Okay. I asked you to do these two as well, didn't I? So yesterday we figured out, right, the scale factor. So we had to cube root in this case because we're comparing volumes, right? So what about this? Calculate the amount of aluminum required to produce the larger can. Aluminum required, right? This is surface area. Asking for surface area. And if it's the larger can that we want the surface area for, we call that the nu. And I already gave it away that it's 404.63. Okay. So in this case, we need to use, right, since surface area is 2D, right, use K squared is surface area of the nu over surface area of the original. Right, we gotta start with that one. We already know our scale factor. We're gonna borrow it from up there, plug it in there. Oh no, it's not a fraction, right? That's okay. I actually wanted that to happen because it doesn't always have to be a fraction. So we're gonna go 1.12, square that. The surface area of the nu is our unknown. The amount of aluminum, or the surface area of the original, can you see up there? Let me just go back up a little bit. It's right here. It's small, but the surface area was provided. And I'm going to highlight that in a bit. So that's 322.57 centimeters squared. I actually had to Google the dimensions of the can to calculate that, right? So there we go. There's your surface area for the aluminum can. So let's square it, right? Take your calculator, 1.12 squared. That is 1.2544. Use all decimals there. And we're just going to continue setting it up. Don't skip steps, guys. It's going to hurt you. It just takes a few seconds. And I want you to see that you can turn this one into a fraction as well. Right? It just blew your mind there, right? But just to see that you need to cross multiply and then divide. So that'd be 322.57 times 1.2544. And some of you already did this, so you're just watching and enjoying the show, right? But there it is. That's how much, and it makes sense. It's a larger can, so I do want a bigger amount there, right? And you might think I was a little off because I didn't square that little makes a big difference. That's why I need to see your work, right? It actually shows conceptual understanding. Let's highlight this here, okay? Where did I get this from? Because you might wonder, where did that come from? That comes from up here. Was given. I have to give you guys, the formula has what? Essentially 3 components to it. You need to have 2 out of the 3 or else no go, right? There's no game, right? So you need to have 2 out of the 3 things. Either they give you the scale factor and one of these, or they give you both of the areas or volumes, and then you need to figure out the scale factor. One more. Determine the height. Height is one-dimensional. That's a dimension. It's just a linear height. So since height is one-dimensional, use K is equal to height of new over height of original. No squaring, no cubing, nothing. This is just one-dimensional. So I'm going to use 1.12 is equal to the height of the original is 12.2. I don't know if you can see it way up there in your diagram. It is there. This is my x, right? Put the 1 underneath. It's just multiplying here. 12.2 times 1.12 divided by 1. That's 13.66 centimeters. That's the final answer there. Before I give you the AC, come with me to page 21. I want you to try, Jasmine, this question right here, A and B. I want you to see if you could manage to figure that out. And remember, everything is connected. Right? I saw enough attempting, so that's good. Let's see how we tackle this one. So there's my scale, which I can easily turn to scale factor, which is 2 over 25. So that's given. That's not required for you to find, right? So that's a good one. And then whenever you see model, like this word model, you're making a scale model or something of something, I would say that you should think of diagram, right? Diagram, diagram, meaning that the other thing is the actual, right? So when you see either the word actual or you see the word diagram, right, you know what the other one will be. Okay, so that's important there, the actual. So I would use wording like diagram actual here instead of new and original. So just to be safe here. So I'm asked to find the fabric in centimeters squared. So you should immediately know that this is the format that I should start with. And this would be surface area of the diagram, surface area of the original. Okay? And then you plug in what you know. I know my scale factor. I'm going to square it. I know the diagram surface area. I know this one. And you, again, the scale factor here helps you to know too, right? The one I'm making, the actual, should be bigger, right? Therefore, a bigger number there. So this is my unknown. Square that, you get 4 over 625, which is 20 centimeters squared over x. Cross multiply and divide like that, right? So it's 20 times 625 divided by 4. That gives you 31.25 centimeters squared. I just did something similar to this. How about we just make sure 1 inch is 2.54 centimeters. If you square the whole thing, I don't have that on my key here. Not the value, I did. That's 1 squared inch has 6.4516 squared centimeters. So 1 squared inch is the equivalent of this many squared centimeters. You can cancel that out and you get 484.38 squared inches. So there's my answer in squared inches. There's my answer, right? Or 3125 centimeters squared. Right? Either one. They're talking about the exact same area required there. Okay. B, if Jasmine made another kite, right, using 500 square centimeters of fabric, this would be considered actual as well, okay? Because you have this model that is being made up there, right? And here, this is the actual kite, another actual kite that you're making, okay? What scale factor, this one right here, tells you that K is unknown, right, would be required to make the model. So basically, what relates the new one, like this one that you made here, to the model that you had originally? And so we will go like this. K squared is surface area of diagram over surface area of actual, right? You are given squared centimeters, right? So you should think it's squared units. So I don't know my scale factor. I'm still trying to figure it out. But the surface area of the diagram is 20 centimeters squared, correct? The surface area of the actual one that I'm just making here has 500 squared centimeters, correct? So again, guys, set it up like this and see what you know. Okay. So my last step is this. First of all, I can cancel out the units. That's perfect. That's what I want. And I'm running out of lead on that one. Right, so this is 20 over 500, but I need to take the square root of that, right? If you want K, you need to take the square root of that. So K is, grab your calculators, 20 divided by 500, and then you go second x squared. I don't know if you found the square root button, but you got to press second and then x squared here. And then copy, paste the previous answer to get 0.2. If you want this as a fraction, you go math, enter, enter again, it's 1 over 5, right? 1 over 5 or 20% if I were to ask you all the other formats there, okay? So that's your scale factor in this case. I do think it's a little, this question is a little unfair. It wasn't quite clear, but again, these are for your notes, so I kind of clarified it there. So just keep that in mind. This one here, down here, I will give you the answer so you can practice that for tomorrow. You're supposed to get 8.75 as your answer. So write that down in brackets. Okay, you try this one. As well as homework would be page 11 and 12 in your workbook. And I think I have a video where I work through this. So if you get stuck, I'm going to try to find it, where I work through these 2 pages. Okay? All right. One more thing for tomorrow's quiz. I'll give you a little checklist. Maybe I'll just post it on Google Classroom. I'll post the checklist as you're writing the AC that I have. I'll post it on Google Classroom. You can write it down on page 26 if you want later on, not now. quiz checklist. And I'll tell you what to expect for tomorrow. Just go through your notes. Go through the notes. Go through the checklist for quiz checklist here. I posted that on Google Classroom. If you want to write it down on page 26, it's there. So all the things that you should still, on top of everything, we kind of parked on the scale factors for now, right? And make sure if you have more time to work on the workbook, I will post the keys to those pages that I've assigned as well. Okay. So, okay, very bottom line, make sure you watch the video to correct the mental math you just attempted to make sure you're on the right track, okay? And then I'll be seeing you first period tomorrow.